Hello, everybody. Welcome to the Brick-RECcon22 online conference. I suppose conference, is that the right? Or yeah, let's go with conference. Well, yeah, so welcome. I mean, this is turning into now an annual thing, and we're very happy to have all of you on the line wherever you are in the world. For me, it's evening at the moment, but I guess for those of you in the US, of course, it's probably in the morning or in the early afternoon. So just before we start, a few bits of housekeeping. We want to make this an interactive session. We have we've got some very interesting presentations for you, but there is the facility to ask questions. So I think if you go to your GoToWebinar control panel, there should be a function there where you can type questions in, and at relevant points during the during our sessions today, we'll be able to take those. And also the presentations are going to be made available after the conference, and there is the URL. So if you guys want to make a note of that, RealEstateCore.io Recon22 is where you're going to find all of the assets from today. So what does our agenda look like? Well, we're going to kick off with a little introduction from myself. Very, very short, but trying to set the scene about why open standards are needed. Then I'm going to hand over to Dr. Gabe Fierro and Dr. Carl Hammer, I should say, sorry, about getting started using Brick and RealEstateCore examples and tools. So I think that's going to be a really good primer for everybody who wants to get a deeper understanding of how these work in practice. Then we're going to take a short break, and after that we're going to come back with Henrik Nielsen. He's the VP of R&D at Schneider Electric Digital Buildings, and he's going to be giving some real life experiences from using Brick Schema and RealEstateCore. So that's going to be, again, a really interesting talk on how this stuff's being used in the real world. Then after that, we'll move on to Dr. Eric Wallin. Everyone's a doctor here, apart from myself, so I don't know, I'm doing something wrong. And that's going to be about what happens next with Brick Schema and RealEstateCore. And then finally, we're going to have a live Q&A with the presenters and Dr. Jason Coe. So again, that's going to be, I think, everyone's chance to ask any appropriate questions that you want to. And then after that, we're going to wrap up. So there's plenty of time. I think there's some great content today, and we really hope that you enjoy it, and we really hope that you can interact with it. And if we'd love to hear your feedback and questions. So let's get started. And I'm just going to give a short introduction, I think, about why standards are needed, and I guess to provide a bit of context, right? So 45% is what is the reduction in energy consumption per square meter that we need to achieve by 2030 compared to 2022 if commercial buildings are going to hit net zero emissions by 2050. And I doubt it's a surprise to anyone out there that actually the International Energy Agency recently concluded that buildings are not on track to reach this or to decarbonize by 2050. And I suppose you may be saying, well, what does that have to do with open standards, which is fair enough. And I think that's why everyone is here today, right? We're here to learn about open standards. But as I believe, you can't manage what you don't measure. And if we don't collect accurate data about what is happening in buildings, then we've got no real hope for efficient energy management, and no hope to reach these important targets that we're setting. Now, of course, the data that you collect from your building does not have to be in a common format. You can operate your building in a proprietary way. You could even do some, I think, pretty sophisticated energy, savings in a proprietary way. And indeed, that's what's happened for many years. There's been basic integration of systems, but not, I think, what anyone would describe as true interoperability. And that's, where things are changing now. And I think with open standards like what we're going to talk about today, Brick and RealEstateCore, we can have true interoperability of systems where data can flow freely, and we can realize the benefits of things like best of breed. So we can start using the best equipment, and that's going to be bring more competition and more innovation to the market, which ultimately is going to mean better commercial building stock. And so, the technology alone is not going to push our buildings to net zero emissions, but I think it is absolutely one piece of the puzzle that we can put in place now. And that's really, my thought to put it in context today. So I'm going to hand over now to Eric. And if Eric, you want to give some thoughts on, what we've discussed, and, that would be great to hear from you.
Yeah. Hi, everyone. Yeah, thank you, Jim. And as you said, I'm just going to give a little bit of a background of why we are doing this. And I think we can sum it up that we are trying to make the buildings into good inhabitants of the smart city. That they are actually working. One of the themes that we had was that basically putting an API on the building, an API that can be open and useful for everyone. And as you said, Jim, we have the sustainability perspective. That is crucial for all of us here. But we also want to use the same data for to empower the actual people that are moving around in the buildings and around and outside of the buildings. We want to be able to connect them to public transportation. We want to be able to make automate compliance processes, reporting, etc. And there's tons of new services that are about to happen and are still not invented using the data. And I think it's all about actually being able to use the already installed sensors and systems in order for new use cases. It's all about that. And then I think when it comes down to this, it's of course the data needs to be shared among others. And it's quite easy to say that, yes, sure, we should be sharing data, but I would say, unfortunately, there is a kind of a not uncommon of data herding from different actors. Property owners, system vendors, cloud application providers. There is a great fear of sharing the data. And but if we have a standard, then you can share data. You know what data you're sharing. So you get control over the data. So I think the big driver is actually to be able to, as Jim said in the beginning, this will not happen unless we have like a standardized way of exchanging data between, and a controlled way of exchanging data. We will not get this kind of we won't get the uplift. We will not be able to do the energy savings. And if you take the next slide, please, Jim. And if we're looking then, if we're looking a little bit back of the history, I think that we started to work with the Brick schema with Gabe and his colleagues. I think it is several years ago. I can't really remember, Gabe, if it's 3 or 4 years ago that we started out to work together. And we have a quite good fit, RealEstateCore and Brick Schema, and I mean we really see that we are both open source, we are both based on semantic web technologies, and we both have the kind of same driver and the same motives to really make something open. And then again, I mean, I'm an engineer. When I started out this venture, I saw that there wasn't any good standards, and the existing standards weren't good enough. So what do? Well, then you invent yet another standard. Definitely guilty, but I mean, I'm trying to make amend now by reducing the numbers of standards, instead making sure that Brick Schema and RealEstateCore actually work as yin and yang. RealEstateCore, as Carl and Gabe will tell you later, is RealEstateCore is dependent on Brick Schema and vice versa in the system. And at the same time, right today, it's much focused on Brick Schema and RealEstateCore, but we are working very, very closely with Azure OS 223p, a little bit carelessly saying the semantic, the next generation of BACnet, the semantic version of BACnet. I don't know if they would agree with my interpretation there. And also we have cooperations with and communications with other standards such as the Haystack project, Google Digital Building, and several others. Building topology ontology, the IPVDI, in order to make sure that we are not trying to make companies choose a standard, but rather making sure that they are working together, that they are complementing each other. We are spending lots of efforts into doing kind of dictionaries between different standards. I think you can switch to the other one. And when you're looking at this, I mean, you could make a simplified explanation of what is Brick and RealEstateCore, and you could say that Brick consists of the device models. I mean, how are you modeling your HVAC systems, your sensors, your IoT devices, etc. And RealEstateCore has been using and following the Brick way of doing this for some time, and now with the and even the previous version of RealEstateCore was using lots of things from the Brick Schema, but with the newest versions we are now adopting totally the Brick Schema way of describing devices, and of course it simplifies extremely much when we're doing this. And RealEstateCore is contributing with the spatial dimension. I mean, it's extremely important that there is no doubt about where did that temperature sensor read it, makes its observation, at what time, in what room, and that room, where's that room placed, in what building, floor plan, and on the world map, where did that happen? So there is no confusion about how you are structuring your tags, trying to describe where the indoor temperature sensor is placed in the building, as an example. And also RealEstateCore adds the needed language to be able to handle the processes of actually operating a building, owning and operating a building. You need to understand which rooms are part of a contract. You need to understand if you have certain conditions in your contract stipulating that you are allowed to increase, to let the indoor temperature rise when there's a certain outdoor temperature, or if you have some sort of health care activities going on, that you are definitely not allowed to let the air pressure go below a certain point. So you can get I mean, air flows that will do some harm. So I think that you can be able to use the data from the systems and then describe them into the different business processes. Not to mention, how can you create a work order from all the different kinds of alerts using some sort of algorithm or so, but then using the expressivity in the language to actually be able to transfer work orders between systems. Then we are really automating everything that we are modeling in the buildings. So this is just a way to try to express how neatly Brick and RealEstateCore fit together. And again, not seen in this picture. I mean, we are so thankful to the building topology ontology group that we are working closely with, and that we have been copying lots of things. RealEstateCore is originally published under MIT open source license. We are switching now to BSD, to Berkeley open source license. That's the same as Brick Schema has. We're just harmonizing it. So everything that we are doing in the RealEstateCore and Brick consortiums is on a very, very permissive open source. As you might know, those open source licenses, you can do whatever you like with the code. You can use it commercially, alter and change it. And I mean, we are really strong believers that you need to be very open. That, I mean, one of the inspirations for RealEstateCore was the schema.org consortium, how that was built. Well, I think I'll stop here, Jim. Just stating this. Thank you.
Thanks, Eric. That's very interesting. And as I said, I think our job for those 15 minutes was to just set some context. But let's get some more detail, of course. Do we have? Where are you, Carl?
There. Yes, I am here. And let's see if I can get permission to share my screen.
Yeah, perfect.
Excellent. And let's hope that I'm sharing the correct screen. Right. And like so. And let's need to switch that around. Apologies. Right. So are you guys seeing my screen properly now?
Yes, we can.
Great. So this is going to be a bit of an introduction to using Brick and RealEstateCore in a fictitious but close to real life scenario that I'll describe to you guys. And then the idea was that Dr. Gabe Fierro would also be able to give a live talk, but as he is probably boarding an airliner just about now, he actually sent us a video instead. So I'll be playing that video describing what you can then do in the RDF world once you continue processing things beyond what I'm doing here. So just quick background there about myself. I'm one of the co-founders of RealEstateCore. Erik Wallin, who you saw earlier, is I'd say one of the other main co-founders. I chair the RealEstateCore technical committee, which meets on a monthly basis and takes decisions on pull requests and on issues and so forth, and actually drives the day-to-day development. Up until recently, I was in academia at Jönköping University, but since recently, since September, I've joined Microsoft, where I work as a technical program manager. But I do want to stress that I am here in a personal capacity, or as in the capacity as RealEstateCore member, not representing my employer. I'll discuss some Microsoft technologies and exemplify with some Microsoft technologies, maybe even slightly promote them because I think they are good technologies, but this is not something that my manager has asked me to do or anything. Conversely, nothing that I say should be construed as product roadmaps or promises or anything of that nature. I neither have those insights than clearance to discuss if I did have those insights. So just so you know. With that out of the way, the scenario I'll discuss, fictitious scenario, Costello Heights, a 3-floor apartment and office building, and how to construct using the combination of Brick and RealEstateCore a digital twin graph for this building that covers the spatial representation of the building, covers some sensors within the building, some systems mounted within the building, and then gets into also this notion of leasable spaces and tenants and contracts. Now, I won't be covering 2D or 3D modeling of the building. When you talk about digital twins, oftentimes people get this vision of something from a sci-fi movie where you'll navigate in a 3D model and zoom in and out. And there are platforms on the market that provide such functionality, but that would be layered on top of a building graph. That's as an added functionality that's not necessarily part of what RealEstateCore provides. This scenario that I'm discussing is taken directly from the guides that we also provide within our documentation at dev.realestatecore.io. And some of it is slightly repetitive with the Brick-RECc webinar provided that we gave earlier this autumn. But if you do go to dev.realestatecore.io under docs and guides, you'll find more expressive versions of this, and you'll find digital twin graphs for Azure Digital Twins and RDF triple representations for these solutions. So you can actually not just get sort of the graphical diagrammatic view, but actual things you can look at and run. So spatial representation, this is basically native RealEstateCore. And what we have here is we're using, when I say interfaces here on the left-hand side, interfaces, that essentially means in OWL parlance, it means class. In Shackle parlance, it would be a node shape. Or in general programming terms, you might call it a type or a class. And we have these classes that describe which kind of nodes you can have in your graph. On the higher order, we have the space. And then beneath that, there's architecture, which is a type of space which has been architected by a human for a purpose. And beneath that, you have things like building and level and room. And these can all be nested between one another using the space has part and space is part of relationship. So you can imagine it like Russian nesting dolls, if you will, where you nest spaces within spaces. So you nest your rooms within your levels and your levels within your buildings, for instance. And here, obviously, the provenance derives back to the building topology ontology that's currently hosted at the W3C Linked Building Data Community Group. So that's influenced this a great deal, as Eric mentioned. And basically, to be able to model this building, we simply have, on the right-hand side, you'll see here the Costello Heights building, which has as parts a lower floor and an upper floor. And each of those floors has as parts a number of rooms. And we can tag the individual spaces with geometry representations in GeoJSON. So if you do want to layer some visualization on top of this, some rendering engine on top of this, you can store those geometries in the graph. But the graph obviously doesn't provide rendering in and of itself. We also have the notion of level numbers, which are on levels. So that is to say floors, which provides you an ordering of the levels within the building. So you'll note that on this diagram, the lower floor has a lower level number naturally than the upper floor. This is all RealEstateCore. This is nothing Brick at all, but Brick is, as I think we've talked about before, going to be adopting this spatial model. So might be useful to know all the same. Moving on to sensor readings. This is where we start seeing this integration of Brick and RealEstateCore. So you'll note that the interfaces that we use here, the points, the sensors, and your temperature sensor, motion sensor, illuminance sensor, these are all taken from Brick. They are Brick concepts. In earlier versions of RealEstateCore, we call these things capabilities, but we found that points is the industry standard nomenclature. So we're using that, and we are taking those points from Brick with their permission, of course. And on top of points, we've layered this last known value, which is something that is new to Brick as well, which allows you to express a recent value for a particular point. So if we look at the diagram here, you'll see that on 2 of the rooms, this is a subset, of course, of the entire building, there are sensors involved. So room 120 on the lower floor has a temperature sensor, a motion sensor, and an illuminance sensor. and room 211 on the upper floor has the same type of sensors. And then on these sensors, you can tag on these values through last known value. And you might ask, why last known value? That sounds weird. Why not just call it, observation or sensor detection or something of that nature? Well, that is because last known value derives from the point type. And other subtypes of points, aside from sensors, include things like commands and set points and parameters. And so we had to find a naming convention for how to express these values that was generic enough to fit on all of those. So last known value is where we ended up. And last known value essentially is a timestamp and a value. And then there's also quantity here, which is an optional metadata you could add on to say, what is it that this actually measures? So the temperature sensor measures temperature. Sometimes it's sufficient to be able to query just based on sensor type, but sometimes you need to make that explicit in the graph as well. There are use cases where such querying is preferred. So this combines then the spatial model, mostly blue nodes from RealEstateCore, with the types or the sensor models from Brick, the orange type nodes there. Moving on, we have assets and HVAC. And here, also, again, we're leveraging Brick classes for equipment. So we're reusing, oh, sorry. There we go, my apologies. We are reusing the equipment hierarchy from Brick. And that includes things like lighting equipment and luminaires and HVAC equipment and AHUs, air handling units, variable air volume boxes, valve boxes, dampers, etc. And so for this little example here, the lower floor has been augmented with two new rooms, the maintenance room and the entrance hall. And those two, and they've also been augmented by an HVAC zone. And the HVAC zone contains those two rooms there. And we'll note that on the bottom there, we have the entrance ceiling light and the entrance door, which are assets that are added on to the or located in the entrance hall. These are not systems, these are our equipment or assets that are mounted in the building, so to speak. Then on the top right there, we have the HVAC related things, the AHU lower and the VAV1 and the damper. And we can express that the AHU is located in the maintenance room. Now, since drawing this diagram, I've learned that you typically don't mount your air handling units in the maintenance room. Bear with me, I'm not an HVAC engineer. So it should probably be mounted on the roof, my apologies. But for the sake of argument, from the modeling point of view, that doesn't really make a big difference here. Your AHU then feeds your valve box, and your valve box has a damper within it. And typically you would feed multiple such valve boxes, of course, and they'd each have dampers and things on them. And on the valve box there, valve 1, there's this point, supply air temperature sensor, which denotes the temperature coming into the valve box, of the air coming into the valve box. And on the damper, there's another point, a position command, basically saying whether it's open or closed. So again, we are combining the spatial model of RealEstateCore, the blue boxes here, with the equipment from Brick. And I think, I'm not entirely sure, maybe entrance door is something we've added on from RealEstateCore as well. And the orange boxes, which are the points hierarchy from Brick. So again, these things work together. The Brick things can be placed in a RealEstateCore spatial topology, and we can feed between them and so forth. So moving on to the tenant modeling aspect. And here, this is perhaps a little bit less orthodox, modeling business processes and organizations and such in your digital twin graph. Why would you want to do that? And the reason is there are certain types of queries where you may want to be able to query your digital twin graph using not only the topology of the building or the sensors of the building, but also the business dimensions of things. So one query might be, okay, if we do need to do some maintenance work on particular pieces of equipment, which tenant does this affect? And if I have the tenants represented and we have their leases represented and the zones that they lease or the apartments or commercial areas that they lease expressed in the graph, I can query across the graph immediately and get that information. Of course, sometimes and most of the times actually you have external systems already that cover these domains. So you'll have to make a choice at some point whether you want to have a full representation of those external systems in your graph, or whether you want to have some mechanism by which you call out and enrich your graph as needed. But we found that having the capability of expressing this either as a full representation or as some sort of stubs for proxying out has been useful in many cases. And in this example, then, we have the notion of agent, which is a RealEstateCore concept, the top level agent. And I don't mean James Bond here, we mean like cognitive agent, and subclasses that would be things like a person or an organization. And an organization in turn could be a subclass of that could be a company. We have the notion of a lease, which we've defined as an event. Why an event? Well, because a lease typically has a duration in time and has some sort of spatial placement, and that makes it an event. Doesn't make an event as in your party, it makes it a long-running event. But still, the same logic fundamentals are applicable. And we have the notion of collection, also RealEstateCore phenomena, where we talk about logical groupings of things that are not necessarily spatially or topology-wise related, but that are administratively related. Now, when it comes to apartments, they are typically contiguous in space. I mean, otherwise it would be difficult to move within your apartment and go from one room to another if it wasn't actually consistent in that way. But not all collections are. So you might take the example of university campus, which would be a collection of spaces, which is administratively a collection, but which is not necessarily contiguous or have a spatial topology that's united. So anyway, what we're doing here is we are defining apartment 1 and apartment 2 as collections. We're defining them as apartment, which is a subclass of collection, and saying that they include a subset of the rooms. We're adding the type lease, so lease 1 and lease 2, the purplish boxes there, which are events, which means they have a start and an end. We also, towards the bottom, have upper floor lease and attic lease. I've added a floor here, the attic floor. And we have the agents expressed as companies or persons, Jane Doe, John Doe, Costello Real Estate, Initech, and Lumberg Incorporated, that have relations to that lease. So this would allow you simply to query for who is leasing a particular space at a particular time. And if you connect that back then to the previous slides, you would be able to say, okay, now we're servicing AHU1, which VAV boxes are fed by this, and in turn, which HVAC zones are fed by those VAV boxes, and in turn, which rooms are part of those HVAC zones. And going back to this model, which apartments include, or other commercial real estate, include those rooms that are affected, and finally, who's leasing those at a given point in time. So that kind of querying is can be quite useful. So this is an overview of the some of the ways in which you can integrate RealEstateCore concepts and Brick schema concepts in building your digital twin. Now, I'm going to be moving on to describe a concrete scenario for how one might then run this in a real-world platform. And I'll be exemplifying with the Microsoft Azure platform. And again, you can do this in many different ways, but I found Azure to work well for me. Now, what I've done here actually is I've set up a little example of my own home. So this is not the same example as Costello Heights necessarily, but I've put hue sensors all over my home because I'm a nerd for this kind of thing. And I'm accessing those using a piece of software called Home Assistant, which is something you can run on a Raspberry Pi or whatnot to run your smart home. And as it turns out, Home Assistant has a plugin that allows you to send in state updates directly into an Azure Event Hub. So that's the middle green box there, U2 Event Hub Home Assistant. And from that, I can trigger what's called an Azure function to ingest that state and put it into my graph in the bottom right corner in the ADT, Azure Digital Twins platform. And from that, in turn, I can emit data using a feature called historization through another event hub and into something called ADX, Azure Data Explorer. And Azure Data Explorer is a really nifty big data storage solution where you can do all kinds of interesting analytics, including, of course, time series analytics. And I'm going to step through and show you some of the slides of what this actually looks like on the inside. A more traditional approach to doing this, if you did not have this Home Assistant, I was lucky to find that Home Assistant had this Event Hub integration. If you don't have that, a more, shall we say, more enterprise scale and a more reasonable solution would be to run something called IoT Edge, which is a container runtime that you run on your server and which is managed by and interacts with something called IoT Hub, which is in the Azure cloud, and then follow the same data flow through some Azure function to update your graph towards the bottom right, and in turn, then onward to historization and analysis. So let's look at what this might look like a little bit more concretely. So this is my building, my home building. No, it's not. My apologies. This is actually the Costello Heights example that I spoke of before. Mixed up the screenshots, mea culpa. This is the Azure Digital Twins Explorer, which allows us to navigate the building graph that we have in our Digital Twins platform, look at the nodes, look at the current values, look at the models, etc. It's a very nice piece of software. So what you're looking at here is the graphical representation of, moving back, these slides here. So the rooms are the same, and the floors are the same, and the leases are the same, and the HVAC zones and so forth. The amalgamation of all of these slides into one digital twin graph, right? So this is the full graph for a very small building, obviously, example building. Now, here is that scenario that I mentioned where we want to do maintenance on the AHU. So I would start by putting in a query for, okay, this is the AHU that I'm looking for. So to select from the digital twin graph where the identifier is AHU lower, that's the one I'm working with. And from then, I can simply double click on nodes and the graph will expand until I find in this case, Jane Doe, who's leasing this apartment that is affected by this VAB box, which will be affected by the AHU, which is under maintenance. And of course, instead of just double clicking on the nodes stepwise and expanding the graph, I could also just as well write a query that provides this graph to me. This is a really nice and nifty and fluent GUI to work with your twins, and I can recommend it very much. Now, so this would be representing on, going back to the bottom right-hand corner there, the ADT Azure Digital Twins graph of your building, where you can look at the now state and look at the topology and see how things are moving. Now, moving into the historization and the data time series analytics. What we're looking at here is a query. Unfortunately, it's in Swedish. I should have localized this to English, but if you're Swedish, read it if you like. This shows that I have now, from my building here now, not the fake building, 8,500 telemetry points over roughly 2 days. And I can look at those telemetry points. These are automatically generated as soon as the twin is updated in the GUI that we saw before, or when new telemetry comes in. these new rows are created in my Azure Data Explorer instance through that pipeline that I measured. So I get the timestamps, I get which telemetry point that was updated, I get the type of that telemetry point, I get the value, and I get the timestamp from the last known value. And this is a different timestamp because that's the source, if you will, timestamp from the source sensor, whereas the timestamp on the left denotes when it reached the ADT instance, the twin graph. Now, I could, for instance, using this, put together a really nice and quick, easy little query to view temperature over time. The query language here is simple enough that a beginner like myself could put together a query like this. I put this together in 15 minutes. Now, so far, I'm only working on telemetry here that is in this Azure Data Explorer graph. So basically all the telemetry has been dumped in there and I'm doing things with it, time series analytics and what have you. Now the power comes into play when you can combine your time series analytics with your digital twin graph. So you can contextualize these time series and do analysis where you select, for instance, only the points that are relevant from a spatial topology or some business point of view. So how do I do that then? Well, I can actually run queries such as this one, where I start by calling out to the digital twin graph and selecting a subset of the points. You'll see there on the third line, there's a select query. And what that essentially does is it calls out to the digital twin graph and says, give me all the points that match what I'm looking for here. So the query that I showed you before, that I could navigate the graph and find which tenant was affected by a certain maintenance work, for instance, that could be expressed as this kind of match graph. Or give me all the sensors. In this case, I think I'm asking for, give me all the sensors which are on the second floor. That's obviously not in the telemetry messages themselves. The telemetry messages themselves only contain timestamps and values and the model of the and the ID of the twin that sent the timestamp. But calling out to the digital twin topology graph, I can do a subset of that which match my needs, which now are to look only on the second floor. I could might as well have a query here that says, give me all the sensors that affect tenant Contoso Inc. or what have you, and give me some statistics on that. So it's a very, very powerful way of taking this large data set of telemetry representation or telemetry points or telemetry readings rather, and being able to at query time select among them based on business needs or business, shall we say, flows or organizations in the twin graph, or spatial or whatever other relations in the twin graph. This is so, and I think the colors don't match exactly, but you'll note at the bottom there that here we have the 4 sensors, all of the sensors that I have, and here one of them, sensor 3, is gone. You'll see that the remaining trend lines are sensor 1, 2, and 4. So apparently I only have one sensor on the floor that was filtered out. So you can build, of course, your digital twin platforms and using many technologies. I found this to be very powerful and helpful and easy to get started with. And especially since RealEstateCore now exists also as DTDL, Digital Twin Definition Language, it works natively with this technology stack. However, if you want to work in an RDF world, and Brick Schema is in an RDF world, there are a couple of ways to achieve that. And that's the next bit here. You can either go to use a native RDF representation and a triple store and whatever technology you want to run that runs on RDF. And RealEstateCore is released also as shackled models. So we release as DTDL for use within DTDL ecosystem, but we also release as shackled for use with RDF and triple stores and so forth. If you want, at the moment, the shackle representation and the DTDL representation of RealEstateCore are kept in sync through a manual process, but the goal is to shortly get that automated such that the shackle representations are generated from the DTDL representation using some continuous integration pipeline. If you do want to use the DTDL representation, but you want to use RDF for other systems, for later analysis and whatnot, our proposal is to use the RealEstateCore JSON LD based API for that. And that basically puts an API on top of your DTDL models and your Azure Digital Twins or other DTDL platform that allows you to query for and get out data in JSON LD format. And JSON LD is a JSON representation of RDF. So thereafter, your RDF-based workflows should just work. And the API is in the GitHub repo. It's the file called rec4api.yaml. It's a Swagger API. I spoke of this one year ago at the last RECcon that we did, but I think it's important enough to revisit it. You can look at it using the Swagger editor and see what's in it and look at the schemas. And there are a couple of differences that I should highlight between JSON LD representation and, well, RDF representation more generally, and Azure Digital Twins and DTDL that have some bearing on what happens here. So I should say that in RDF world, typically your field declarations, so that would be your property shapes on your node shapes, or your object or data properties if you're more generally on your classes, if you're more in OWL world, are global, right? They have global identity. So you'll have a name, you'll have identifiers like, brickschema.org/bricks, hashtag is point of, something like that, or not. Whereas in DTDL, your fields are local to the interface that defines them. That's a very, very important difference here. And similarly, in the RDF world, your identifiers for your nodes are globally defined, typically using URIs. So you'll have http://mydomain.com/mysystem/UID, whatever, would be your identifier. Whereas in an ADT and Azure type platform, your twin identifiers are local and don't include those URIs. So those are some differences here, and we've had to reconcile those when constructing the API. There are more differences, of course, but these are the most relevant ones when discussing API. So the design for this API is basically what we wanted to build, wanted it to be as minimal an overhead as possible. Ideally, just add a JSON LD context to the twin objects that are returned from Azure Digital Twins, and have a reasonable subset of our interface declarations become endpoints so that you could run CRUD operations on them. So /rooms, for instance, would give you access to all the twins that implement or that are instances of the room interface. /points would do the same for all the point nodes that you have, etc. The selection for actually which endpoints to use is actually underway. We had a technical committee call about this yesterday, and hopefully within a week or two we'll have nailed down the details for RealEstateCore 4 general availability. We use the Hydra vocabulary for pagination because you can't return all of your hundreds or thousands of twins at once, or tens of thousands. And we use JSON API principles for querying. So these are, I mean, if you're not familiar with these things, basically your developers will be, and they are not difficult. So looking at how it might look, this is an example of a JSON object returned from an ADT type platform where we've grafted on the JSON LD to express this as RDF, as JSON LD. So we grafted on the context, the identifier, and well, the types there. And this essentially enriches the payload with semantic details needed to then be able to disambiguate things and have a clear understanding what things mean. These contexts are generated per type. And what the context does is it provides a file where you can look up and say, okay, these fields that I have down here, architected by and owned by and has part and whatnot, what are the global identifiers for those? How do I resolve that? And we can look at one example context here. And here you'll see the difference then between traditional RDF and this use of DTDL, because you'll see that these field names, area, for instance, is not defined using a global address. Well, it is global, but it's under the architecture underscore contents underscore area URN. That is because in DTDL, area is defined as a field on the architecture interface. So this looks a little bit peculiar, of course, but it is not invalid. It is actually valid RDF, just looks a bit weird to you. If you think it looks weird enough that you can't use it and you want to normalize it to something that is more traditional, well, you could simply do an alignment between these names and global names as used in the shackle version of RealEstateCore and Brick, and run a line-by-line replace across your data file. And that's not very expensive if you have that need. When it comes to these global entity identifiers, the solution that we're working on for now, the easy solution here is, as you see at the very top there, ID, is that we are prefixing the identifier with the identifier of the Azure Digital Twins instance that hosts this particular twin. Because on that particular instance, the identifier is going to be unique. So the combination of that host name and that identifier is going to be unique. Of course, a more proper long-term solution would be to set up a more long-term namespace management, because you might not always want your twin to remain on that particular instance, for instance, or you might have other IRI minting conventions. But this is an easy solution for a quick interface, so to speak. And finally, and this is a little bit nerdy perhaps, but hopefully you are okay with that. This is the triples representation of that JSON LD object I showed before, the RDF triples that come out of this. And this you can pipe into whatever RDF ingestion pipeline that you have to do your RDF analysis on that. And vice versa, you could, using put requests on that API, ingest RDF data into your Azure Digital Twins platform on the other hand, and in turn get the value of these things like the Azure Data Explorer that I mentioned before. So I think I'm at the end of my slide deck. I'm gonna pause right here and see if I can now move on to Gabe's talk. Because Dr. Gabe Fierro, again, he couldn't be here because he was boarding a plane, but he did prepare a video. So let's see if we can get that on screen. And when I start playing this video, I think that it will automatically mute everyone, including myself. I hope you guys will hear it properly. And if not, someone is going to have to stop me.
Hi everyone, I'm Dr. Gabe Fierro, and I'm going to be talking a little bit about Brick and RealEstateCore in practice, specifically from the RDF perspective. Sorry I can't be there in person virtually. I'm on a flight to a conference and I'll actually be pitching a little bit of our work in that conference during this talk. All right, so just a little bit about myself. I recently finished my PhD in computer science, and since then I've begun an assistant professor position at the Colorado School of Mines, as well as a joint appointment as a research engineer at the National Renewable Energy Laboratory. Of course, I'm not speaking on behalf of either of those organizations today. Today I'm representing my role as the sort of co-founder, co-creator, and lead developer on the Brick Ontology project. Okay, so just a brief little outline of what we're going to be talking about today. Talk a little bit about Brick and RealEstateCore alignment timeline in terms of the specifics and what that means for Brick. Also going to be going through a couple techniques for metadata model creation, giving you a little bit of tutorial on the shapes constraint language, or shackle shapes, as well as shape-driven model development. How do we make sure that the models we're developing are actually useful for the kinds of applications we want to be able to run? And lastly, I'll be showing a little bit of the fun that we can have with a BACnet, BOP test, and a Brick/RealEstateCore model, basically working with a simulated digital twin. Okay, so first, the Brick timeline for the Brick RealEstateCore alignment. We're anticipating to be able to release some of these the ontology changes in version 1.3.1 within the next few months. That should probably read into the next sort of 6 months or half year. But basically, there's two efforts that we're going to start with. First, we're going to take existing Brick properties. This would be has location, has part, the relationships that are at the core of Brick. We're going to expand those to make sure that they're compatible with RealEstateCore classes. Currently in Brick 1.3, the has location property will point to a Brick location class, but because RealEstateCore is taking on the location modeling, we're going to make sure that the Brick relationships are compatible with that in an upcoming release. We're also going to add shackle rules, really ontological shapes, to infer RealEstateCore types for existing Brick entities. So our goal is to make sure that existing Brick models continue to work, continue to function, even as we begin to more clearly delineate the roles of these respective ontologies. So by incorporating these new shackle rules into existing Brick projects, we'll make sure that existing Brick models are interpretable by anything that's RDF facing. We'll make sure that those models will automatically include the RealEstateCore types. This should also provide annotations that make it possible for you to perform this migration automatically, or through your own tool. You don't have to use shackle, but it's definitely easier to do that. And then further, as we move into Brick 1.4, which is not something we're currently talking about in Brick, but 1.4, 1.5 would be 1.4 would be when we release those deprecation annotations for Brick classes, so that when you're validating your models, it gives you a heads up that you should be using RealEstateCore types rather than Brick types. But again, through that process, we're going to make sure that existing Brick models are compatible with RealEstateCore models, and make sure that we're adding those annotations and those types so that they are sort of fully compliant with this unified vision that we've put forward. All right, so now I want to dig into techniques for metadata model creation. Basically, for the longest time, the dominant thinking has really been to convert as much of that existing metadata as possible into your structured linked data form. So all the BIM metadata, all of the point labels you're getting out of your BAS or your BMS, try to convert as much of that as you can, your mechanical schedules, into your Brick or RealEstateCore model. However, that's really still open loop. Really, there's no feedback mechanism to make sure that the effort that you're putting into creating that model actually produces a model that you're that's actually useful for the things you want to use it for, right? So how do you know what to do first? How do you know what to do at all? And are you making sure that you're adding that metadata in a correct and discoverable manner, right? And we haven't really engaged with this piece, but this has been a big focus in Brick 1.3, and it's a big focus for a lot of the tooling that we've been actively developing. And so what I'm going to talk about is the use of shackle shapes, and don't worry, I'll define what that is, but shackle shapes and how those help close the loop on metadata model creation. Okay, so what is a shackle shape, and why do we need them? So we can think of this, we can consider this initially from the perspective of application requirements. And application requirements come in many different kinds of forms. Here is a screenshot of the ASHRAE Guideline 36 document describing sequences of operation for high-performance HVAC systems, and this is for a particular system configuration for a VAV terminal unit with reheat. There is another part in the standard document or the guideline document where they talk about how exactly that a piece of equipment is put together, but from the perspective of running different sequences of operation, of running different fault detection rules, these are the points that you need to have available in your backnet or your network or your whatever that BMS system is. You need to have these points available so that your controller or your software can read and write from the places it needs to in order to enact that logic. And so the question that shackle shapes solve is, how do you make sure that your model contains the right metadata such that it is consistent with this table? So this motivates the shapes constraint language, or shackle. This is a W3C standard. This is not something that we created. This is an existing standard with existing implementations that we are applying to this scenario because our metadata efforts are built on the RDF data model. So a shape is essentially a set of constraints, requirements, or conditions on parts of a graph. So you can think of this set of constraints and requirements, as really just a function that returns true or false when evaluated on part of a graph. It also gives you, if the answer is false, it also gives you some information about what went wrong. Why was the result of validating this false? Why was that part of the graph not valid? And so here's sort of a very simple little shape for another kind of terminal unit in Guideline 36 called the cooling only VAV, so it has no reheat coil. And so you can think of that graph as saying there should be some instance of Brick VAV that has a point relationship to exactly one zone air temperature sensor, that's the part on the left, and at most one zone air temperature set point. And this is, for the sequences of operation, let's just say for the sake of discussion that some of those work with just the sensor, maybe these fault detection rules, and some of them work without the set point. So at most one set point, exactly one sensor on that. And if we take some input graph, so there's an input graph on the left, it's just a simple brick model. If we input that into the shape and we call our validation function, then you're going to get some report. And that report identifies that, well, there is an instance of Brick VAV, that's the VAV1 entity. There is an instance of the set point, and that's connected through the has point relationship. And so those two nodes on the right-hand side are green, those are good. However, there is no zone air temperature sensor, and thus the restriction or the requirement that there must be exactly one associated with this VAV is not fulfilled, and thus the overall validation function fails. So VAV1 does not validate on the shape 4.1 VAV cooling only. Okay, so what's in a shape? So we have an identifier. The shape has a name. This is given by an RDF IRI or a blank node, if we really get into the details, but you can think of that having some IRI. A shape also has a target. This is a specification of what parts of the graph the shape applies to. So the common examples of this would be any instance of a given class, any subject or object of some relationship, or you could even say run this shape on specific nodes in the graph, that VAV, that sensor, that zone. A shape also contains a set of constraints, and this is really where the meat of the validation happens. These are the conditions that have to be true for the shape to validate on a node. So any shape that validation process executes on a particular node. And those targets really produce sets of nodes that then validate it on the shape. And so constraints give you types. Those constraints can be on the types of things. They can be on the values of certain properties. They can be on the cardinality of those properties or the cardinality of instances. You have string operations. You have logical constraints. You have different graph structures that you can constrain. So there's really a huge variety of things that you can express. And if you can't figure out a way to express it using the shackle language, you can always use Sparkle to basically execute a query that tells you which parts of the graph may or may not fulfill your constraints. Okay, so let's go through a short example for an FDD rule set. This is again from ASHRAE Guideline 36. This is a point list for a single zone air handling unit. And there's many more to this, but I'm just showing 3 points here. So the system specification as defined by ASHRAE guideline 36 says you must have an outdoor air temperature sensor, and optionally you can have a mixed air and optionally a return air temperature sensor located within that piece of equipment. And if we take a look at tables of default rules, also defined by ASHRAE guideline 36, we can see this one here, where it compares the mixed air temperature and the return air temperature and the outside air temperature, and basically just makes sure that the mixed air is between the outside and return air temperatures. Otherwise, mixing isn't happening correctly or something else is going on. And you can see actually here in the text of the standard, they've said, omit this rule if there is no mixed air temperature sensor. And of course, that's something that a human can apply, but what Shackle does is it allows us to reason about what would it mean for a computer, right, to identify the fault conditions that could run on a particular model without any human input or direct input in determining what those rules are. Okay, so I went ahead and wrote this these shackle shapes already, so I'll sort of walk you through what's going on here. So we're going to start with the point list for that single zone unit. So here's the beginning of that shape. You can see here I'm using SH class, so that's a part of the shackle standard. Say any target of this shape, so anything this shape is going to apply to, must be an instance of Brick air handling unit. There's also this SH property annotation, and what that is, and anything that starts with SH property identifies a block of the shape that constrains the kinds of properties that target can have and what must be true about that property, what must be true about its value, what must be true about its relationship to other parts of the graph. And we can see in this case, there must be at least one has point relationship to something with the class of outside air temperature sensor. That's what those lines inside those two square brackets are telling us. So we can add two other properties. Again, remember, outside air temperature was required per that point list, but both the mixed and return air temperature sensors are not required, so they both have a qualified min count of 0. These qualified constraints help differentiate between different uses of the same property. When you're reading through the shackle standard, you may be tempted to use min count rather than qualified min count, but I would encourage you to sort of keep a close eye on what those definitions mean, and when you are reusing properties, you want to be able to use the qualified variations of these. Just one implementation detail that tripped me up when I first got involved with this stuff. Lastly, I'm going to find another shape here. This one will automatically apply to all points. So in the first one, I have SH class because I don't want all of my air handling units to necessarily be considered single zone, but I do want all of my points in my model to adhere to this shape, which says they must have at least one unit, and that unit is defined as an instance of the QDT unit class, which is another ontology. So we're going to make sure that all of our points have units. So that will automatically apply to those instances of the sensors associated with the air handling unit. And we also say, here's what must exist on that air handling unit in terms of the points that it has. Okay, so now we can start with a simple brick model. Here I'm declaring just an instance of the air handling unit class called AHU1. I'm also explicitly saying this should match the single zone unit shape. So not all air handling units in my building are single zone in this case, so I am explicitly saying which ones should adhere to which point list or which shapes. We execute shackle validation. There's a variety of tools that will do this. The one that I use most often is PyShackle, which is a Python-based implementation that's free, fairly performant, and has done just a really good job of adhering to the standard. The result of executing shackle validation is a validation report. And we can see that this one here says there's a violation on the min count constraint component. That source shape there really refers to part of the shape on the previous slide, and that's something the software can tell automatically for you. I'm not expecting you to understand what underscore N593 is, but if you ask the software, it'll point you to the right thing. It says that AHU1 failed, and it failed on the has point relationship, right? And so this is enough information for me to go back to the shape definition and figure out what I need to fix or what went wrong. And the result message is there was less than one value. So this is the min count. I needed at least one outside air temperature sensor. We can see in that brick model there that there isn't one, and thus that condition failed. All right, so now if I go and add that has point relationship to the HUOAT1 entity, and I declare that entity as an instance of outside air temperature sensor, then execute shackle validation, the report's going to return nothing, which really means everything is okay. Okay, so far we've been able to make sure that our air handling unit instance is compliant with the point list, but it is not yet, we have not yet determined whether or not it is compliant with the actual fault condition rule. If you remember, the fault condition rule needs both the mixed air and return air temperature sensors, but the point list said that those were optional. So we're going to write a new shape here using the exact same principles, the exact same sort of structure of the shackle shape to say, well, if it's going to run the fault condition rule 2, it needs to include at least one mixed air temperature and at least one return air temperature sensor. Here we're also requiring, so this SH node basically is pointing to that other shape, saying we're also including those requirements of the single zone air handling unit shape. So this is a shortcut, so I can ensure that this also includes the outside air temperature sensor. Obviously, this is a determination that you need to make for your own use case of whether or not you want to compose these or not. Here I'm just doing this for illustrative purposes. Yes, and of course the new shape requires that both the mixed air and return air temperature points exist on those units. Okay, so we've seen a little bit about how to write shackle shapes, how to execute that validation, and how to interpret the validation report, or what that validation report is. And now we're going to look at how to interpret that. The validation report says which conditions failed on which nodes, and it's sort of on to you, the human, to interpret those reports to figure out what to add or remove from that model. But it's actually possible to interpret some of those validation reports to repair models automatically. And that's actually what why I'm not here in person, is because I'm talking about some of our work in this space. The work is called Application-Driven Creation of Building Metadata Models with Semantic Sufficiency. This will be presented on November 10th. The paper should be available online shortly after that. And it formalizes a notion of semantic sufficiency, which states that a building model is complete when it contains sufficient metadata to execute the set of applications or use cases that you intend. We also create this notion of templates, so ways of generating parts of this model automatically with very little input to make sure that everything is regular. And there's actually is going to be an open source tool and library of these things to be released alongside this paper, and we're hoping to release that within the next couple months, so keep an eye out for that. Okay, so now I wanted to touch on Brick and RealEstateCore in simulated practice. What might this look like on a simulated building? So we have the Department of Energy published a set of reference buildings. This is the medium office building. It incorporates a simple forced air system, 5 HVAC zones, 1 air handling unit, and then 1 reheat VAV per zone. And what I've done here is shown the class graph of this. This is, rather than all the entities and all the instances, I'm showing how types of things are related to one another. So you can see the relationship between the RealEstateCore floor and building and HVAC zone and the brick equipment, the air handling unit, the reheat VAV, heating coil, pump command, the points, the zone air cooling and heating temperature set points, temperature sensor, and the supply air temperature sensor, right? So this is the model that we've created to represent this reference building published by the United States Department of Energy. Now what I can do is embed within that model these references to the BACnet network. And so here's an example of executing this query on that model. You can see I'm asking for anything that's a sensor, that's a point of a zone, so associated with some HVAC zone, and then I'm asking for any of those sensors, is there a BACnet object identifier that would allow me to go into the BACnet network and start pulling out live data. And you can see here in this building, we've got 2 of these. we've got both the supply air temperature sensor and the zone air temperature sensor associated with the south zone on floor 2 of the building, and you can see they both have BACnet objects, numbers with incident numbers 135 and 134. Okay, so we can now discover live BACnet objects. Of course, the model's been created to encode that information. And what we can do is actually, because there is a live simulation of this building, we can actually start to plot this and engage with the simulation as if it were a real building. So what's going on here is we're using BOPTest, which is an open source wrapper around Modelica and Spawn of Energy Plus that simulates the building faithfully to its sort of the physical arrangement and presents the results of that simulation using a REST API that also allows you to write into the simulation. BOPTest provides a variety of realistic test case buildings. We've happened to choose this particular one because it's relatively simple. And you can see here the zone temperature changing in response to the modulated supply air temperature. So that supply air temperature is in purple, and you can see that light blue line slowly rising back up to the minimum set point. So what we've done is for each of these test case buildings, because there's a simulation there, we've actually wrapped that in a virtual BACnet network. We've modeled the building and the network using Brick and RealEstateCore, and we've incorporated that all into a unified package that allows you to engage with simulations as if they're real buildings. You can run unaltered BACnet code, so the BACnet Explorers, BACnet Discovery software, anything you want, you can run that as if it were a real building. You can also write Brick queries and RealEstateCore queries to discover information and pull that out. I'm also going to be presenting this Anon's going to be presenting this at BuildSys on Thursday. On the 10th. There is also an open source repository behind this so everyone can play with it. We're using the wonderful Backpipes framework to virtualize the network, and of course the hard work on the open source projects of BOPTest to make that possible as well. All right, and that's all I have. Hopefully that give you a little bit of a picture of both how to use shackle shapes to ensure that your model contains sufficient metadata to execute interesting applications that incorporate data, as well as being able to play with these things in a safe environment on top of a simulation that doesn't remove you too much from the way that real buildings actually work. Here's some additional resources: the Brick ontology documentation, sort of developer focused, at docs.brickschema.org, the Brick source repository, and the Brick source repository and the Brick resources both contain the information for Brick 1.3, which we released just a couple weeks ago. If you have questions or comments, or you want to contribute, please feel free to contact me. My email is on my website, gtf.fyi. I did also recently make a Twitter, so you can contact me there as well.
Great stuff. Are we back? Yes, we are. Can everybody see my screen? Yes. Great. Well, thank you so much, Carl. Thank you, Gabe. I hope you had a nice flight. And now we're going to take a 10-minute break. We're a little bit ahead of schedule, but that's no problem. Just leaves more at the end, more time at the end for Q&A. So by my watch, we should come back at about 27 past the hour, and then we'll start with a presentation from Henrik from Schneider Electric. See you guys in 10. Thank you. Okay, everybody, welcome back. So after our little break, let's get on with the next presentation. And this is going to be looking at real life experiences from using Brick Schema and RealEstateCore in EcoStruxure. And this is going to be another video presentation from Henrik Nielsen. He's the VP R&D at Schneider Electric Digital Buildings. So please just give me 1 second and I will bring it up. So again, we should be muted. If there are any issues, please put it in the chat and we'll be able to deal with it. But yeah, here we go.
Hello, I'm here to talk about our real-life experiences from using Brick Schema and RealEstateCore in EcoStruxure. I'm Henrik Nielsen. I'm the VP of R&D in Digital Buildings, Schneider Electric. Our journey towards open, standardized building models, leveraging RealEstateCore and Brick Schema. I'm today covering a couple of challenges, moving from theory to practice, making twins at scale, and managing the full building life cycle. But first, a few words about Schneider Electric, a leader in energy management and automation. When we look at buildings of the future, we talk about hyper-efficient buildings. 30% of the energy used in buildings today is pure waste. We believe in maximizing the performance by optimizing system and workflows. Resilient buildings to recover quickly and bounce back. Buildings are exposed to external threats like cybersecurity attacks, power losses, flooding, etc. Sustainable buildings. 40% of the CO2 today is coming from buildings. We need to consume less, extend life of assets, and spend energy wisely. People-centric buildings. Ensuring comfortable buildings, productive settings for all people. We spend 90% of our times in buildings. We deliver technology infrastructure in the EcoStruxure using the EcoStruxure architecture. And this is a three-layered architecture where we talk about connected products, edge control, apps, analytics, and services. End-to-end cybersecurity and scaling from on-prem to cloud. This architecture we apply to buildings of small to large to portfolio level. First experience I'm going to talk about is about our learnings with RealEstateCore. So the first experience, I'm going to talk about the project with a company called Vasakronan. Vasakronan is the largest Swedish real estate company. There are many buildings throughout Sweden and Nordics, and they're geographically spread out. They're lacking the right tools and instrumentation to drive efficiency. And the technical infrastructure in buildings, they come from multiple vendors and different phases of the life cycle. They have a significant installed base of TAC, Schneider Electric building management systems and controllers in 40 plus buildings. So the challenge and vision we discussed with Vasakronan is really to leverage an open platform for portfolio management, PropTech OS. They were to digitize, model, and connect all current buildings into this platform. 2, be able to drive efficiency and create savings, deliver value and services to customers. In this project, Schneider Electric's role was to be a partner and to support this evolution and to implement a solution for RealEstateCore in EcoStruxure. And what it really meant is really to modernize, to go from, to the left here, an initial infrastructure of buildings in 2 main cities, Stockholm and Uppsala, and to modernize this platform into the newest generation EcoStruxure, and then to integrate the solution to RealEstateCore powered solution into PropTech OS. On the right side, you see the press release from May this year, where we actually have instrumented the building operation into 16 buildings in Stockholm and Uppsala, connected to the PropTech OS platform. Now, we started this journey a bit over 2 years ago, and this is the first time we get around to learn about semantic technology, really. And we started with BMS using the building management system and exporting data into point lists and tagging manually these data point lists with the RealEstateCore tags. And to complement that, we built a standalone data connector, a bidirectional REST-based connector that we're able to talk northbound to a cloud system called PropTech OS. And to the right, you see the architecture, and this is the first drawing that we exchange with each other, the proof of concept, where you have the digital twin living in the PropTech OS platform, powered by RealEstateCore, and you have the data providers to the left, and EcoStruxure being one. One big discussion we had was really about the bidirectional part of data actuation and how to handle liabilities and safety between the platforms. And in the end, after some hard work, we did deliver on a functional but not really scalable solution here. And I think there was clearly concerns about complexity and support over the life cycle, etc. But we did connect the platforms all together. However, we also came to a realization that really to go all the way, we need a commercial solution. So we decided to take it into the core offer, and we built a native integration using MQTT-based data connector with the RealEstateCore compliant payload, with RealEstateCore compliant data mapping, and we built in safety nets to manage value ranges and offline scenarios between the platforms and how to manage them. In addition, we also extended and improved the modeling tool that is key for the onboarding process. And in the end, we accomplished to become a PropTech certified partner. The current deployment status is we have 4 full buildings with 17 servers pushing 2,000 data points and receiving 500 writes from the PropTech OS platform. And currently we have ongoing 2 buildings with 7 additional servers pumping data to the PropTech OS platform. So what did we learn from this? Yeah, first of all, I mean, this was the first exposure to ontologies and RealEstateCore, and we learned really the basics of RDF and modeling, and really appreciate the collaboration on this. Second part was about real-time data integration, the challenges that came with bidirectional communication, and the need for the robust safety nets to protect, and lots of discussion around liabilities and contractual aspects of if something happens, who's responsible, and we need to protect the assets. Third, about onboarding, the need for industrial scale requires really high level of efficiency. I mean, also to plug in a system into a digital twin on the cloud is really, we need to be able to do that with augmenting the existing control, not having to reprogram. Then, of course, the simpler the better as always, and automatic onboarding as far as we can do. Lastly, about the life cycle, and need a really robust deployment and with a clear service level agreement. Because we need to manage change over time if it's upgrades or changes to the facility and new capabilities. So these were the big learnings with a very successful project together with RealEstateCore and Vasakronan. The next chapter is about Brick. and it's really complementary to the journey with RealEstateCore. And the first experience we have here in the market is really, I mean, I'll start from the market perspective. We see more specifications now starting to refer to tagged buildings and open access to data with semantic context. And we see in specifications all over the world that the brick is becoming a very important standard, and compliance with it is really important. So today I'm going to talk about the project in Sydney, Australia, for the Circular Quay Tower. It's one of the big tall buildings here on the screen. So Circular Quay Tower, and this is an overview of the construction. It's a 54-level high building and multiple tenants. And you have a mix of tenant space, suites, plant room, and a business center. And in front of the building, there is also a square where you have two more buildings. So it's all part of one system here. So this example here is where we're leveraging our Edge platform as the integrated system platform. And in the integrated system platform, we really talk about different roles here, but to be the single user interface for various subsystems. Dashboards to display summary level data, centralized alarm handling, repository for log data, reporting, scheduling, and a full single pane of glass for the system. And we're talking about many subsystems here, very integrated building. So the building management and control, CCTV, security, energy monitoring, workplace sensors, lighting and emergency lighting, fire system, lifts and vertical transport, blind control, critical power, integrated comms networks, flood systems, and car park systems. All this integrated into the building, leveraging the EcoStruxure platform. So this is some examples of kind of how the screens for operators look like. To the left, you see the workplace view, workplace sensors and status for different floors. And then you drill in and look at specific conditions on the floor to the lower left. To the upper right, you see the building management and the environmental and climate conditions in respective floors. You see on the lower right, you have the energy management status for meters, etc. on floor levels. You have then the communication network, the racks status. Yeah, on the bottom, you see the car park information, and you also have the flooding system. So a lot of data coming together, integrated into one single pane of glass. Then what is then behind this? So first, I'm just going to start to say that I think we have two worlds here. We have the more physical operational database with all the equipment modeled into the standard kind of object hierarchical system. But we have also augmented this now with a twin database on the edge, where we have modeled all the aspects of the twin in parallel to the operations DB. And this is where the journey starts. So first, I want to talk about this modeling and how we bind things together. So we had the green database. This is for operations database. And then we have the gray database, that is the twin database. So to really connect these two together, we bring life to the twin. And this enables us to bring leverage semantics in our operations. So what we have done here is we've extended the brick schema with a few new relations, like has property, has trend log, has alarm, has scheduled. So we have added that to the gray database, creating links in between. And now you can start to kind of talk between these data. And only the property reference here is the one that is user configured, and the rest is automatically populated between the twin and the object database. And on top of this, then you have a middleware where you then can access the different data independently. So this is the first, using custom extensions in Brick to connect models with real data. The next learning is about the depth of modeling. So, and here we go back to custom extensions again. We have a lot of different subsystems in this building, and the model in Brick is not 100% complete, of course. So there is this need that we need to be able to extend the Brick model on project basis, but also as much as possible push generic parts into the standard. So one example here is in the area of blind. So that was missing. Blind equipment was missing in the standard, and also blind group as a collection was missing. So we pushed that through the work groups in Brick, and now it's part of the Brick 1.3. So this is a very important way to extend and to contribute back to the forum. And we see the need for this to improve the standard, but we also see a continued need for managing extensions on the project level. Next topic is something that we have run across, is that model creation is super critical, and the simplicity in it to do the twin, develop the twin. So we need simplify and guide model creation by context-based support. And today you have good ways to validate models using Shackle, but we also need to implement a really context-based support for this. So when the user is building the model, he can actually see a subset of selections and what he can do while he is creating it. So this is for us an important need for Brick in the future to help with capabilities to allow that. Next challenge we went into was really about access rights. So this building we have is actually a multi-tenant building, but we have a single graph for that building. And we need role-based access rights to this graph information. And we don't want to configure every little entity in this graph. So here we have different methods that you classically use. You could have one database per tenant. You can have a shared database and shared schema. And you can have a shared database and a separate schema. And what we actually did here was really we implemented a smart filter strategy based on the graph pattern applied to a tenant. And actually that resulted in a model similar to the left, but with kind of an auto-generated solution based on a master database. So this was very critical to us because we have multiple tenants that want to be isolated from each other. Next topic is about data sharing. Again, this is an emerging field, and data scientists want to be able to access any type of data without necessarily having exact use cases. But we need to be able to share graph information, we need to be able to share time series information, and consume anything. So we built a kind of middleware based on native MQTT from operations. Middleware supporting both Sparkle queries and REST-based API to access data. So this middleware is now put in place for this Circular Quake, our project, and now we can access anything from the databases. Another learning was about internationalization, and again, we need to localize the ontology for the end user. So we actually present information related to the knowledge graph, and we need to do it in a local preference. Of course, all the instance names, etc. for the entities are in local language, but also the classes and relationships needs to be translated for the end user in our implementation. So we implemented support for localization, the language part, the engineering units, etc., as part of this support. And lastly, the lifecycle management. The need for a robust system and process to manage change. In this learning with the Circular Quiet Tower, we started with the base building, and where in the construction phase, we were able to complete a lot of the modeling. At that phase, the tenants were not really defined yet or agreed. So the second phase of the modeling that could typically happen after the construction phase is done is the fit out. And then every tenant space is being modeled as part of this twin. So it's a bit of a continued modeling of the life space. And then, of course, the life cycle its own, with space changes and tenants coming and going, etc. So the need to be able to enter data once in this ecosystem and to make it in a process where you can make sure and have a structured way to keep track of changes. Extremely critical. So we can easily say that we made a lot of learnings from these experiences. So first, I'm recapping on modeling, the data references back in the Brick schema. External references has now been incorporated in the Brick schema 1.3. We have the custom extensions and how to drive that through standardization. We have the context-based validation to simplify model building. And the way to manage access rights in a graph. Role-based multi-tenant scenario. Data sharing for third parties using APIs and middleware to get international acceptance into translation and engineering units, and how to in a good way manage lifecycle through robust deployment with clear SLAs and to manage change in a simple and efficient way. With that, kind of summarizing the learnings, and that's really complementary, and really look forward to the continued journey on RealEstateCore and Brick, and wish you all a great conference. Thank you.
Great stuff. Thank you, Henrik. Very, very interesting presentation there. I think with some real good insights. So let me share my screen again. 1 second. There we go. I hope you can now see the presentation again. And we're going to carry on now with the next presentation. And that's going to be by Eric again. And he's going to talk about what happens next with Brick Schema and RealEstateCore. Eric, are you there?
Yes. Hi, James.
Hi.
Thank you very much. Can you please? This will be quite brief but important. Can you take the next slide, please, Jim? So, I mean, what is ongoing and next? We heard before, and I mean, we can sum it up that the general availability for the RealEstateCore is before the end of the year, and Brick Schema, as we heard before, is a little bit later, and even a little bit later with the 1.4. But hopefully I can talk now for Gabe and Carl and say that we are basically having done an enormous amount of work during this year. We started out this journey for real in January this year, and there has been lots of work being done by Carl and Gabe and lots of other people. What we also have been doing is that we have been doing more things in our SDK, more and better toolings. There has been Carl has been working with quite a lot of translators, and especially self-service guides. If you're checking out the RealEstateCore website, you will find guides that are actually extending even more to what Carl was showing earlier today. And we are looking for, and there are lots of different companies that are working with RealEstateCore that has extensive SDKs and with the code examples for different languages and ready-made frameworks for different kinds of connectors to underlying systems, as well as there are quite many different application providers, both in things such as FDD and energy optimization, but also in co-working and in the facility management systems, etc. So there's actually quite a vibrant community of things out there. And of course, you can reach this. There will be more links. The links will be at the end of this presentation, at the end of this conference, both to Brick and RealEstateCore resources. What we are working with, this is actually a repeat. We have been working with a really important part, and that is the business administration side. And there is a very good another consortium, open source consortium, that is called IPBDI. And I know that we have business software software developers that are focused on ERP system and business systems are working with them there are several working within this on a global level, trying to harmonize, because many times when you are interacting or integrating with the business administration system of some sort, they are of course not RDF or DTDL based. They are SQL based. So there is of course challenges that we're working with on how can we bridge these different kinds of these aspects of, because as you probably know, there are I mean, it's quite an effort to say that you should be replacing some parts of your business operation systems. I mean, many times that won't happen. It will probably take a long while before we will be seeing those systems being graph based. So that is a really important cooperation that we have. Also, we are working with, of course, energy. Lots of different actors within the RealEstateCore consortium are working at that. There's one interesting work that a Dutch company has done that's called OG-E, that they are, I mean, you have to classify all the components when you in the batteries, solar panels, etc., and the different things that are happening between those when you are starting to optimizing. I mean, optimizing energy consumption and ventilation in a building, that is a tough task enough as it is. But when you start to involve storage, consumption, production, prices from the grid, other kind of demands, contractual limitations, it's quite a multi-dimensional problem to handle how you're doing optimization on this. There's also an important work that we have been doing, and I can also, I'll jump to the procurement requirements in a while, but we're very, very open to suggestions, and that if someone is actually taking part of the work that we are doing in trying to improve this. I mean, we are working with waste management or recycling companies, and of course they are the experts in the domain, such as OG within the energy domain and others. So we are extremely happy to get feedback, and as I said before, and on the last slide of this presentations, there are links to both the Brick schemas, communities and resources, as well as the RealEstateCore. So reach out on Gitter or Google Groups or in GitHub. Then I'm going to talk a little bit about another thing that has arisen over the years, and that is that when we are talking with property owners or construction companies specifically, they are extremely eager to know what things should I buy. when you're talking about property owners. What systems should I buy in order to be compliant into the future? Yeah, and of course, if you have a crystal ball, you could tell them exactly what they should buy. But I mean, in lack of a crystal ball, we have been working with a couple of construction companies and large property owners, and of course vendors to produce an official document for procurement. And if you can change the slide, Jim. And so we have an official procurement requirements, and this is now written specifically for RealEstateCore, but actually in the latest version it's 4.0, which means that this applies for Brick as well, because RealEstateCore 4 is of course is dependent on the Brick classes for devices. So we have this now in Swedish, in Dutch, English, and French, and there are different entities that are working with this, or different companies and individuals that are working with these within their local language regions, and we probably will need different versions within even covering different language versions. But this is extremely helpful because this one stipulates how a system, the API on the system, how that should be specified. And from a property owner's perspective, I mean, the old-fashioned way is that when you get the building, when you take a building into when you take the ownership of a building from a construction company, you're doing your revision and you are checking that the lights works and ventilation, and of course much more complex. But you are really not that. You don't really care about what kind of APIs do I have on the building, what kind of data output do I have, what are the SLA, as Henrik said in the previous presentation, extremely important to stress, so you have the same expectations from property owners and from different suppliers. What have you promised? And this is an official document that you can use as a standalone legal document in your requirement process, and it's available on GitHub. And it is also, and that is, there are some people have found some corrections in these documents, that there have been some either spelling errors or there have been some improvements, and there's actually also some of the languages have been done by other people and then being published back to RealEstateCore. So here's just a shout out to everyone that's listening to this, that don't hesitate to, if it's not in your language, take the English version or whatever other version, and then help us to translate it for your local region, because I mean you have so many special building codes in different places. But there are quite many projects that have been built and procured using this, and there are quite a lot right now that are being procured and constructed using these requirements. The building I'm sitting in right now was one of the first building that was procured and according to the RealEstateCore requirements. And on the previous slide, I also mentioned that we have a similar document for BIM modeling. That one is work in progress. There is an old version of that one dating back to 2018 that we did, a couple of consultants and property owners together with the RealEstateCore consortium. There is a much better work through version that we will be able to publish at the RealEstateCore website as well. Well, I think that was my last slide about where we are standing on RealEstateCore and Brick. Thank you, Jim.
Thank you very much, Eric. And that sounds fascinating. I'm definitely going to go and download that document. I think it's such a useful tool for people who, you know, it's often the case that it's not easy to procure software like this, and it's very easy to overlook certain details. So I think this is a great initiative and well worth supporting. So okay, I think we've arrived now at the Q&A session. And Jason, are you going to join us for this one? There's a few people coming online, aren't there? So we can keep this up for now, and I think if people want to turn their cameras on when they're ready to come in, and yeah, Q&A basically means questions. So of all the people listening, we'd be very happy to take some of your questions. Now is a perfect time to ask some people with a real deep knowledge of these open standards, what they would like to, yeah, what their opinions.
Hi James, by the way, I'm here. Just needed to find the button to unmute.
No problem. Nice to have you, Jason.
Mm-hmm.
So no one has asked a question yet, but I mean, we can kick this off between us, right? Where should we start? There's been a lot covered, hasn't there? So I don't know, maybe just a few takeaways would be interesting, right? I mean, what is it? Maybe we can start with you, Jason. What is it that you're going to take away from this session, or that you want people to take away from this session?
Sure. Yeah. I really appreciate all the. First, I appreciate the opportunity to discuss with you guys. I haven't met you before. I mean, I met James before some time ago, but still, it's been a while. And also happy to participate in this discussion and all the great presentations. I always wondering how people are actually using Brick and RealEstateCore and how they implement it in their systems. What are the technical challenges in the real world use cases, especially with the Henrik's presentation about EcoStruxure's integration with Brick Schema and RealEstateCore was amazing. I personally learned a lot, and I hope that people got more senses about how it is used and the potential challenges that they may face once adopting those into their system. So I think that sharing those experiences down the road is really important for the community to adopt the technology and the ontology. Yeah, so happy to discuss more on that.
I think for me as well, with not having much technical experience, especially compared with you guys, I think that for me, that Snyder presentation put things in quite a lot of context, right? So I can understand sort of conceptually what we're doing and what the purpose is, but actually, as you said, seeing how it comes together in a real world application, I think was fascinating. And indeed, Carl, your house version as well was very interesting.
Well, yeah, well, I suppose I did two houses there. One is my own personal house that I'm wired up with things just because I'm the kind of nerd who does that. But then, of course, we had the slightly larger fictitious house there for the example. My reflection is, two reflections. One is that I've been notified by the organizers that there are 15 plus questions in the questions panel, so we need to go to that panel. But aside from that, I'd say the reflection is, wow, this thing has taken off a lot more than I thought a couple of years ago. So, and that's not necessarily due to any particular brilliance on the part of the founders. Sorry, Eric, and sorry to myself, I guess. But it is, well, we've done something which is, I think, is usable, and there is a great need for it. So a bit of luck with timing and a bit of luck with positioning, with sufficient usability, sufficient academic credentials perhaps, and sufficient degree of applications and implementations that are actually running out there. So the Schneider one and the PropTech OS and well, the stuff that we're running on Azure Digital Twins and so forth. And I guess that's one of those differentiators compared with some other more sort of, shall we say, academically based ontology initiatives, not necessarily in the smart building space, but in the general semantics and ontology space, is that we've focused on getting something into production, something that works from early on. And that I think is crucial. But I suppose we continue with the questions.
May I just add, Jim, that to Henrik's speak or the presentation, that he started out saying that what actually happened was that when they built a native built-in RealEstateCore natively into their EcoStruxure as a commercial solution, I mean to the EcoStruxure 2022, that is their 4.0, the latest version of it, was that when a normal onboarding of a building, I mean the kind of job when you are trying to decoding tags and other stuff, was 20 hours on average for roughly 20,000 square meter building. When we were onboarding these systems, it dropped down to 2 hours. So I think you actually saw the scale when you have the standardized when you have a standard, you can do it at the I mean, it was a factor 10 in efforts to do it. So I think which actually then rendered this kind of big order on one bulk from that property owner because of look how much we are saving and how faster it goes. And as Henrik says, when it comes to life cycle management, when you are then refurbishing to see how you're stop sending emails with CSV files with tags when you're refurbishing, and you're using APIs, so you're doing it in the proper way, of course increasing quality tremendously as well. Yeah, I'll stop there. That was just an addition to Henrik's.
No, it's great. And I was going to ask you, of course, about your takeaways, but I agree. Like it is fantastic to see. Well, and it must be just all the hard work you guys have put in to actually see these real world cases and actually people using these open standards and getting the benefit from it. So yeah, it's fantastic. Had a bit of an issue with the questions, but we are getting them in the chat here now, so I'm going to just take them as they arrive. And I don't know if maybe you guys can decide between you who would like to take the questions. So number one, to get the last known value, and that maybe this applies to was it Gabe's present? No, was it Gabe's or yours, Carl? I can't remember. Sorry. The last known value. Do we need to store the time series data in the graph?
Yeah, so I think that's at the intersection of Brick and Rec. So Jason, I guess as the Brick representative, you go first.
Oh, thank you. I mean, I had some context about the last known value thing, so I want to share that, and Carl, maybe you can add more. So Brick was hesitating to adopt the time series values into the graph for some time because most of the use cases, building analytics, some visualizations, and so on, they need to be represented as a whole time series rather than just one single observation. So we always urged people to use the different types of the databases for the right data model for different data sources. Like time series can be stored in a time series database like timescales and so on. So, and then we adopted the concept of references, so we can refer to the exact columns or rows or the some indexes in the time series data from the graph. But after then, we also realized that accessing the latest or the last known value is pretty a common use case because you need to filter based on the current status of the systems from the graph as well. And if you need to query over both of the databases, that's a pretty painful. So we also, in addition to just the reference to the time series database, we also adopted the latest known value, which can be liably updated by a certain connector to the bracket devices or any sensors. So we do support both of the cases, and both of them serve different purposes.
Okay, thank you. Carl, anything to add?
Yeah, no, I think that captures it very nicely, and I think that exactly, these are different systems used for different purposes, and keeping time series data in your graph will bloat your graph, and it's not optimal for that type of analysis anyway. But as you said, Jason, having the latest value is something that is a common enough use case that that's supported. But if you want to do something with time series, push your telemetry into a dedicated time series system. In my example, it was Azure Data Explorer. It could be whatever time series management system you have, but ensure that there are links in between so that you can query back and forth as needed to fulfill the business case.
Great, let's take another question. 1 second. Here we go. Question 2. After the latest release of RealEstateCore version 4, the concept of sensor equipment disappeared. At the same time, Brick does not have such a concept. Is it envisaged? Oh, sorry. 1 second, it just disappeared. I've got to go back. Is it envisaged that to add such as sensor equipment and others like gateways back to one or both ontologies?
Yeah, I think, or Jason, you go first, sorry.
Yeah, I mean, during the meeting, during the presentation, I just replied to the same question in the Brick community. So I thought I owe an answer to that. There's more context in that thread, so please check our Brick Google groups where we openly discuss many topics. The short answer is that we will work on it. We do recognize that there's a few missing classes between the transition from the RealEstateCore to Brick, and there were some reasons that why we didn't have something and why we want to have something in the future and so on. But we will work on it and adopt those. Please keep posting those more needs to Brick community, and we will respond as soon as possible.
Yeah, and I think this was one of those things that came up rather early on in the discussions actually with the Brick consortium when we started this alignment process, was that the Brick equipment hierarchy is a lot more fully fleshed out than RealEstateCore used to be, and it didn't make sense to keep sort of an amalgamation of both, but rather it would be better and more consistent to use only the one, and the one that was more developed was at that point Brick. So that's why, but there are some things that were missing from Brick, and I think we said early on that this is something we'd really like to see added to Brick. And I don't know whether it's on an issue list in the repo yet, or whether it's still on a discussion basis, but my understanding is that that's something that's probably going to happen at some point, because there is a clear use to be able to describe not only the logical points, but also the physical boxes in the building.
Mm-hmm. Okay. A RealEstateCore question here. Can RealEstateCore model or link to schedules?
Right, so that's actually something that as late as yesterday, I punted from the long-term roadmap, because it's been in the long-term roadmap to represent bookings, whether it be bookings of classrooms or what have you. And we basically said this has been on the roadmap or in the issues backlog for a long time, but no one has stepped up to actually build it. And since it is a community project and we haven't had the prioritization for many of the core developers, we'd be happy to take submissions to that. What we do have is we have, of course, the lease semantics there, and you might want to represent, or there might be some overlap there such that bookings are subclasses of leases, or at least some similarities in modeling that may be worthwhile looking into. I mean, after all, what is a booking of a room other than a very short-term lease of that said room? Perhaps paid, perhaps not paid, depending on what your financial setup is like. But long story, it could certainly be added. There is nothing for scheduling in RealEstateCore at the moment. And if anyone wants to contribute that, we would be very happy to initiate that process.
Great. There you go. To anyone listening, add that to RealEstateCore. Question 4. How does RealEstateCore deal with changes over time? Say a room is renovated and split into 2, but the sensors stay at the same location, or a tenant moves in or out. Oh, good question. What do you say, guys?
I mean, this goes to core of one of those fundamental ontological challenges, which is how do you represent time in RDF? If you're in a property graph type model, which DTDL is, you can actually throw properties on any relationship edge. So you can basically that way say that those edges are valid from a certain starting time point to a certain ending time point by adding properties to the edge denoting the starting and ending. But in the RDF world, that's not yet possible. There is something called RDF Star that is under development, led by Olaf Hartig of Linköping University, just around the corner from me, actually, which essentially adds the ability to express triples about triples, so you can emulate that kind of thing to be able to add essentially statement level metadata easily. And in that way, you could add time indexing to anything really. However, that's not something we do at the moment because that's not developed yet. So in some cases, we express time explicitly. So the leases is an example of that. The leases are time bounded. They have a start and an end. So if someone moves out, you shut down that lease and you create a new lease for the new tenant, or if they change the objects they lease, you close that lease and open another lease, basically. That's how you would represent that. But for other things, we do not yet have that in the model. So typically the splitting of the room there is no first order representation in RealEstateCore to show spatial change over time. And that is an open challenge for sure. It may be possible to treat that, I'm speculating now, but it may be possible to treat that in the same way as time series historization. So basically shift such events to a system that is built to handle time series data of some sort, only not just telemetries, but perhaps more complex objects there. Conceivably, that's a solution one might look into, but I have no good answer for that. How to do that right now.
I can add a little bit about that. On an implementation level, I mean, the Brick-RECcon system that I'm working with is one among lots of different RealEstateCore brick platforms. There we're handling the changes of anything, spaces or leases or anything, in an audit trail similar way, as you say, Carl. So you can keep track of changes and you can see when and who made the changes. Then you're solving the kind of business problem that you need to understand. Who was responsible for editing the digital twin graph? So that is just and then that's just an implementation. It's, even though, as Carl said, it's not supported out of the box. I mean, we've been discussing quite much all of the provenance when it comes to maintaining digital twins. Isn't there a provenance ontology, Carl, that we've been looking at, or the prov ontology? But from our side, when we are making platforms, we are just handling it in an audit trail fashion, and then we're solving the problem.
Okay. Here's another good question. What is the added value of having BIM in this graph-based scenario?
I don't know if I can start a little bit. I mean, the big challenge that you have is that when you're looking on a traditional BMS system, if we start from that starting point, is that you have tags which in some way it's encoded building ID, floor plan, room number, or whatever kind of schema that the responsible technician that started out setting up a BMS system was using. And then when it comes to, I mean, BIM is a very wide concept. But if you're looking on that, you could take data from the IFC format, I mean, the more kind of generic format that you can produce from different kinds of BIM model programs, then of course it's extremely valuable to have the spatial relationship, to understand where a room is, how a room is described and how that one is being placed. So, I mean, having BIM models as source data is extremely helpful. So you can then place sensors in them. I don't know, Jason or Carl, if you would like to add something there.
Yeah, I think having the single interface to access the information from the application side is, simplifying the application development experiences, and the relationships among the spatial concepts are one of the common use cases, like what is the closest room to this one, and what is the path towards this room to that one, and how many people could have occupied this, and how many people are actually occupying this, which is information that you can extract from the BIM models. And we would like to have them in the same model, the same place where applicable. Yeah.
Okay, good stuff. Technical question here. Why JSON LD API instead of Turtle? Isn't Turtle more minimal?
Developer familiarity, pure and simple. We want to, I mean, this is going to sound pretentious as hell, so I'm sorry, but we do want to change the world, right? We want to make this accessible to a lot of developers. And Turtle is the easiest or the simplest RDF representation before JSON LD, but it is not as simple as JSON LD. And the number of people who know JSON outnumbers the people who know Turtle by, 1,000-fold or more. I'm guessing here, but so adding on context and ID and type blocks to normal JSON is still very parsable by developers who want to build an app that does something or a system that consumes something. Definitely a Turtle representation might be more terse, might be more in line with the traditional semantic web RDF community, no questions there, but that's not exactly who we're targeting. So that's the rationale for that. And also, I mean, for the sake of simplicity, adding on those blocks onto the ADT platform or another existing platform that you already have is a lot simpler engineering-wise than building something larger.
Okay, yeah. Anything to add there, guys? Should I take the next question? Okay, I have a couple, two questions I think here. It's interesting to see RealEstateCore being deployed in Sweden. I was wondering how different language characters can be translated into metadata or schema. Like "sure" is a Swedish word. How can we translate it? So I guess, yeah. How do you deal with different languages in these models?
So generally speaking, both DTDL and any RDF representation is localizable. So any literals can have language tags tagged onto them. So you simply add, whenever you have a string, you add a language tag, and you can add multiple strings with multiple language tags so that your model is native in whatever language that you've added, the strings for. So that's built into the specs. More broadly, I mean, if we want to get a little bit ontologically, philosophically deep, there is.
Sure, why not?
If specs follow culture and culture follows language, or something to that effect, right? So if you get into the really the weeds of detailed or foundational ontology modeling, you know, how do I define what an event is? Does a tree fall if no one's there to hear it, kind of thing? That is definitely informed by culture and or does it make a noise if no one's there to hear it? That is definitely informed by culture. And so there are sometimes cases where you get internationalization challenges due to simply underlying foundational ontological differences. Those are very rare in applied domains such as buildings and sensors, which are, you know, you can touch these things most of the time. So long story short, use the built-in language features for localization and avoid modeling things that are foundational and complicated. Jason, anything to add?
Yeah, I want to distinguish two things, which is ILI or ULIs to represent the entity in the ontology versus label in different languages in a human interpretable way. And ULIs technically can be anything. It can be even arbitrary characters, like we can call a baby just ABCD, and then as long as all of us agree on that is a VAB, we can use the ULI, sorry, ABCD as a ULI. But of course, that needs to be translated into a human language in a way, and any ontologies have the capability. I don't say they already have it, but they have the capability to represent multiple languages in the human labels. So Brick has studied, you know, from most of the American buildings in the initiation. So we tend to have the American styles of the conventions in the words, but we do intend to introduce explicit labels in different languages, and happy to have more contributions there. And I will start from mine.
Actually, I skirted the issue that you bring up there, which is not only the labels, but the identifiers themselves. And there, I would say the convention generally is to use English language labels or identifiers, because that's in the cultural context that we're operating in, that is most commonly recognized and parsable. You could use opaque ones, as Jason says, but that would probably reduce the value of the models more than it would improve the value of the models. We did come across an interesting aspect of this just a couple of weeks ago when someone asked on our GitHub repo, why are you so inconsistent in how you name identifiers? Because Brick Schema uses underscore case and RealEstateCore uses Pascal case. So we concatenate words, you know, temperature sensor in RealEstateCore would be temperature sensor in one word with capital S and capital T, whereas in Brick it's temperature underscore sensor. Not the same thing as a different language, but definitely a different sort of design choice for that. That kind of thing we probably won't be able to get away from without alienating either of the two communities. But aside from that, labeling that's sort of user-facing, when you get to GUIs and whatnot, that labeling can be multilingual by default, so to speak.
Okay. Comment and a question here. Great talk, great tools, thank you. What do you think Brick can help to reduce the carbon emissions on existing buildings? And is there any demo or tutorial for how to use Brick? Jason, I think this one's for you.
Yeah, sure. An easier question first. There are a lot of demos and tutorials on our website, brickschema.org, and probably resources and documentation. We put a lot of effort on making it easy to, you know, test it on your laptop, deploying some Docker containers containing multiple components so that you can test out the data and so on. So please check it out and let us know what you like, what do you expect to see more, or the questions or any comments. And the how to reduce the carbon emission by using Brick. Of course, Brick alone is not a tool for reducing the carbon emission, but it can help deploying any business logic or the auditing tools, using auditing tools in a scalable way with Brick, because it can output the consistent data with which you can develop more applications to reduce the carbon emissions. There are more focused projects more focused on carbon emissions related to Brick, like building sync for auditing reports, and there are other FTD tools developed on top of Brick, and of course more analytical visualization applications and so on, which could potentially help the reducing the carbon emissions. I think it is same for any other ontologies aiming for standardizing the building data, like RealEstateCore and Brick together. Yeah, it's definitely a way to go.
Definitely. Will there be an explicit set of ASHRAE guideline 36 points and equipment mapped to the guideline in Brick?
Yeah, so Gabe should have been here for precisely answering this one, but I do recognize that there is an activity going on, especially with the ASHRAE 223P working group, which is a semantic data modeling, and which is fully aligned with Brick, and it is using more detailed concepts on top of Brick. So I believe that there's also an example using guideline 36 mapping to Brick as well. I'll check with Gabe and see if there's any reference that he can share with the broader community.
Okay. Yeah, I can't see who asked that question, but I'm sure if whoever it was, if you reach out to Gabe or anyone at Brick, they'll be able to help you.
Yep.
Okay. With COVID impacting the segmentation of VAV and building locations, have there been discussions, in particular relative to health and building processes, with a BMS? Yeah.
Yeah. I mean, I can share my experiences, and then of course anybody can add more. The VAV, traditionally the building optimization is focused on the trade-off between the tenant comfort versus energy efficiency. Like if I decrease the temperature, it may improve the tenant comfort, but increase the energy consumption. But with the COVID impacting it, COVID impacts, there's another dimension of the trade-off, which is air quality. And which means that we need more information about VAV's capacity, AHU's capacity, and the schedules of the tenants inside each zone, and what are the possible schedules of the cleaning and so on. So the importance of having normalized data has increased because of the COVID. And we did introduce more properties related to those, and we do have more air quality sensors related to that. So Brick is helping in a way, but actual implementation and the policy should be set up outside the Brick community, like ASHRAE or other health organizations, and happy to coordinate further.
I can add a little bit. I mean, we have situations where you have different kinds of health services, like health centrals, where it has been extremely important that the airflow is not allowed to drop below a certain level. And when you are using an application for using AI to optimize the indoor climate versus the energy consumption. Then we have another case, and that is like on operational centrals. I mean, this maybe not straight out of COVID, but when you can see that getting the data out from how many times and at what point of time was the doors open to the operational room, and then of course this is extremely sensitive data, but then you're exporting this data to some other analytics environment where you can map to see over time, over all the operations that have been done, and see if there's a correlation between opening, people entering the operational room and any side effects with operations. I mean, that's examples of how you're using the BMS data to support a better health situation. It's not explicitly COVID, but in the same domain.
Yeah, good one. Okay, okay, interesting. We've got a metaverse question here. How about that? With all the talk of metaverse standards about interoperability between worlds, I'm curious if there are any discussion about merging real estate ontologies into the conversation of an open metaverse.
I can just say it's already been done, and there's a really cool New York company called Solar Media, and I could see if I could put the link here, that has done quite much job between, oh, what is the biggest name of a gaming platform? It's called the big
Unreal Engine.
Unreal Engine, BIM models, RealEstateCore, and sensor data. And I don't know if that message will be visible to everyone. I'm trying to post it in the chat. Organizers. I'll try to post it here, and let's see if I can get some help from Matthias to. Oops, that was the wrong one. Organizers and panelists. I'll update this recording later, or I mean, I will add it. But that's really cool how they're using Unreal Engine, BIM models, RealEstateCore, and sensor data from RealEstateCore platforms to mesh everything, and they've done quite much job on that.
Wow.
But more broadly, I suppose the question, a relevant follow-up question then is, if we are trying to build a technical ecosystem and a data exchange ecosystem using standardized semantics, can that paradigm carry over into this metaverse discussion, so that this becomes not only this one cool one-shot thing developed by this cool company, but a standardization that you could, something you could put on your own building, and where you could traverse these Unreal Engine instances, if you will, in your Snow Crash style metaverse of the future. I mean, technically there are surely barriers, but not unsurmountable ones. Definitely not. So we'll have to see. Sounds like a cool thing.
Yeah, totally. Okay, we've got 3 more questions here. Here we go. Do you see the application of data from BMS for beyond building the application, for example, end user services? Can you reflect more on the digital twins? Any tips? What is a good digital twin and what is not? Anyone want to take?
Yeah, I mean, in terms of use cases, when we started on the RealEstateCore side, one of the earliest things, of course, was this driver for energy optimization, and that immediately ties into then BMS and HVAC and that entire domain. But in parallel with that, we always had, and I think Eric had also in his earlier slides, this notion of, shall we say, empowering the tenants or providing services to the tenants that they could not previously have using previous solutions. So not only having how to run your AHUs and whatnot, but also being able to say, I live in a rental building and I can use a RealEstateCore backed digital twin platform to figure out whether the shared laundry areas are available for booking or what have you, right? Or a scenario I used to pitch a lot was, it would be really cool if in my bookings.com or hotels.com or whatever profile, I had my preferences in terms of temperature and in terms of lighting and in terms of other things embedded, such that when I booked a hotel, I'd get those that configuration carried along with me. And that's also the kind of thing that you could definitely imagine having by standardizing semantics for not just the BMS and not just the operations of the building, but more broadly the use of the building. And it's something that could be very clearly sort of end user facing, definitely. I think we've had other, I mean, when you take your coffee machine in your shared office landscape, is that not only a specialization of the notion of a lease? Again, going back to the booking scenario, which is definitely end user facing. So I could have, I suppose, my mobile app that would grant me access or not to the coffee machine or to a shared conference room or what have you. I think those are fairly end user facing. So yeah, definitely something that is within scope of a digital twin using RealEstateCore like semantics. Then there was something else, some other part of that question as well that I didn't answer though. What DT is good or not, so something to that effect. I think you're muted.
Sorry, I was muted. Yes, no, I said there was, the second part of the question was I guess some reflections on digital twins that they were interested in. But I mean, and this has become a popular term more recently, hasn't it, to describe, I think, something that is, again, not particularly easy to describe, right? But
Oh yeah.
maybe you got reflections on what it is, and is there such a thing? Is there even such a thing as a good digital twin and a bad digital twin?
I think what we've spoken of, at least internally, I don't know if we've gone public with this or to how large a degree, but has been you want to be able to express the structure of whatever thing you're looking at, whether it is a building or a piece of machinery or what have you, sort of the topology of that thing, the structure of that thing, how it fits together, how it to some degree works to, you know, whatever degree is usable for your use case. And you want to be able to express the state of that thing. And in many scenarios, I think I said this earlier, people have this notion that for it to be a digital twin, you need to put on your 3D glasses and see it in 3D space and navigate and touch it and move it around. That's what digital twin is. From my point of view, that's a nice to have. It's a nice addition to have visualization, but it is not a prerequisite for calling something a digital twin. So I think that's a nice usability add-on to have. I think that's about how I try to package a digital twin. So containing sort of the structure, whatever you're looking at in a digital representation, and the current state of that thing. And of course, you know, the ability ideally to interoperate with it digitally, to actuate something, to, you know, unlock doors or to start an engine or what have you, whatever is relevant to your business context.
Mm-hmm. Good.
But I mean, that's off the top of my head and based on some earlier discussions we've had. I'm sure there are people who've thought a lot more about this among the panelists.
Have a very long conversation about it, I'm sure. But we only have about 15 minutes left, so we have some more questions. I was wrong, apparently, by the way. We have more questions. So let's see if we can get through all of them at least. Maybe, yeah, we'll see. We'll see how we go. I'd like to, I guess this is a comment, not so much a question here, maybe a comment. I'd like to put OSCRE, I don't know if I said that right, sorry, OSCRE on your radar, 20 years history in real estate standards, development, open source and free. Implementing multiple standards together is a major challenge. How would you advise implementers to make choices on which standards to use and how to work with multiple standards in an integration setting, and how to sync this with data governance and data management practices? Who would like to take that?
Yeah, I haven't seen OSCRE model before, but it's definitely interesting. I'm just looking at it, and it has a lot of stuff inside. The way to pick up the ontologies that you need is you need to understand your use cases first, and then starting from there, you want to at that point you know what you need to model for implementing that application, and then you need to do some footwork for finding the right ontologies for accommodating all the cases that you want to model. Brick and RealEstateCore has have its own target use cases like building analytics and developing applications on top of the buildings. But if you need sorry that I didn't recognize this OSCLE yet, but if you need something that is not in Brick Schema and then something inside OSCRE, you can start looking into them and see the commonality between those ontologies and map them. And we can definitely help in that process, like between RealEstateCore and the Brick Schema, like several years ago, we knew that the equipment and Brick equipment and the RealEstateCore set have the same concepts. So we started mapping that high-level concepts first, and then we came to this to fully integrate. But the mapping of the common concepts is the first step towards work using multiple ontologies.
I'd like to add a reflection there, which I don't know if this is relevant to this particular group that was now added, and I will have to show my ignorance in not having read up on this group. So, but I think we need to be mindful of that the term standard means different things to different people. And what RealEstateCore is about, and what I get the sense that Brick is about also, and some of the other ontologies that we've mentioned, are, shall we say, technical standards, web generation standards, open sourced, come and build your implementation based on what we're doing kind of thing, delivering technical machine parsable deliverables, much like your web RFCs or your IETF or whatever, or W3C specs. Whereas standards in the building and construction industry historically tend to draw more towards, in my impression, the ISO type standards. So which basically is you have a membership structure, you need to pay to enter. You work in a long time as an industry group with corporate partners to develop what in the end turns out to be a very well written and extensive PDF report, which is not necessarily executable in code. I'm painting with a very broad stroke here, and I do not mean to alienate or upset, but these are slightly different things for slightly different use cases, perhaps, or slightly different traditions. And I just think it's important that we're mindful of that when we talk of standards. So when you come to things like governance and these sort of more, shall we say, higher order business aspects of standardization, I think they tend more towards the latter kind of group, whereas that's not something that we are intricately familiar with when building technical standards, roughly.
Yeah. And I think,
again, a very broad brushstroke there, so please don't shoot me for this.
No, and I think, Carl, I think we have been quite taking lots of influences over how the internet was built with RFCs, and also very much from schema.org, which has been also this kind of very open. I mean, we are very open. Anyone can post in GitHub a suggestion or shoot us down if we're doing something terribly wrong. And I think we have also always been saying, Carl, that running code is trumping everything. I mean, if you are implementing it and showing that it works, that is a really important part, that it should be implemented. It should be tested in order to get in. So I think again, when we have our governance principles, which is very straightforward and very influenced by schema.org standardization, which is and knock on wood, it has been actually been working quite well up and so far.
Okay. Since RealEstateCore is open source, is there any way not to liaise on Azure? Is there alternative to Azure subscription?
Yeah, and this is super important for us to be clear on, because RealEstateCore started now 6 years ago now, and as time progressed, of course, we collaborated a lot with Microsoft, and since recently I am myself an employee at Microsoft. But it is important to know that RealEstateCore is an independent non-profit consortium consisting of a number of independent companies. We do release the spec as both Shackle and as DTDL. So if you want to use RealEstateCore and RealEstateCore and Brick in the RDF Shackle world, then there is a Shackle version that is released and will be supported, long term. If you want to use the DTDL version, which is logically more or less the same, there are some edge cases because the logics aren't exactly the same between, of course, Shackle and DTDL, but conceptually more or less the same. Azure is probably the prime deployment platform for that. That being said, there's a DTDL parser available in the NuGet package repository, which you can use to build quite interesting solutions on top of other stacks. And these days, .NET runs anywhere, so you can consume that package and run that on Linux or on Mac OS or on your Raspberry Pi somewhere. It doesn't really matter. So you could certainly, I could imagine you might be able to put it on top of some other graph database and still use the DTDL version to define your API and your types. So you're not, there is no inherent dependence on the Azure platform, but it is definitely the most straightforward way of running DTDL-based ontologies, that's for sure. And if you want to use something else, then absolutely, again, use triple stores and use the Shackle version, or use both with the API that I mentioned earlier.
I know several other platforms that runs it on top of Neo4j, as an example. That's not
using cloud-based sort of alternatives, or is it just Azure at the moment? For example, do Amazon or Google have their own?
Well, so Amazon, for instance, has a triple store in the cloud, and I've forgotten the name. Could be Neptune. I don't know whether they support Shackle fully or not, but there is they at least have a triple store, which I hear good things about. And as Eric mentioned, there are people who run RealEstateCore on top of Neo4j, and Neo4j has a cloud offering as well. So definitely something that is technically possible if that's your thing.
Mm-hmm. Good. Okay, here's an interesting question. Many of our MEP and BMS engineers believe BACnet and its standard identification keys are enough for most of the use cases. Would you, or basically, would you not agree? And if you don't agree, why? Anyone want to take this one?
Yeah, I can start. I believe Eric and Carl, and even James, you might have some opinions on it too. But I do see why the MEP and BMS engineers have such an opinion that the BACnet may be enough, because their job ends with configuring the BMS systems and configuring the controllers. But we wanna expose the potential of we wanna establish the potential of those data by exposing to more applications or other business analytical apps. And in that case, you need to because at the configuration of the BMS systems and the controllers, what individual objects or points would actually mean and their relationships because you're the designer. But when you want to share that information with somebody else, you need to stick to a certain ontology to represent that is shared with others to represent what they actually mean. So I think that's the primary difference of why it may be necessary for some people, may be needed for some other people, and it is important to understand different roles.
Yeah, absolutely. Any other thoughts from you two guys?
I can say, I mean, we usually, there's one example. I mean, now I use identification keys. It tags. I guess you're meaning with that. When you are encoding like the serving system that you are encoding, that is the air handling unit. And Jason, please set me straight here if I misunderstood the question. But we have examples of then you have identified that one in the tag or in the identification key for like a sensor, but that sensor might be serving not only the ventilation system but also the heating system or the cooling system, and that way it's that you have to make a selection. And we have many of those cases when you're trying to decode the tags and now try to understand when you're trying to transfer it into RealEstateCore, and they are limited because the temperature sensor are encoded for the ventilation system and maybe not for the cooling system or the heating system. So I think it's you can't get as rich description. You can't get these explicit things. You are quite limited in when you're making like an incremental tag that is describing a relationship. Mm-hmm. That's my opinion.
I think it's valid. No, I mean, I agree. I think that it's about perspective, isn't it? And I'm of course, you know, someone who works on commissioning and installing building management system, I can understand that perspective. But I think what we're trying to do here is be beyond that, right? It's and takes data from various sources and creates a richer model. Anyway, let's take one more question because we're almost out of time. While you are sharing that there is lots of examples of Brick and a few examples of RealEstateCore, where can we find examples of both working together? And this is a great idea, a great point for you guys to plug the websites. So go ahead.
I can just start by saying that we were considering to have I mean, RealEstateCore is and Brick is not in general availability yet. So I mean, the most implementation that we see are these kind of demo things and other stuff. But there is actually, I know of one quite large systems, and I hope that we can ask Peter Hartleb to come and present this, which has actually implemented this in live production. But it's, I mean, we are until we have it frozen down in GA now quite shortly, then we will start rolling out this at a quite large, wide scale.
Okay, so basically to be continued. Look out for it soon. Yeah.
Yeah.
Good stuff. Okay, well, that kind of wraps it up for us tonight. And maybe, I mean, just finish off by saying thank you, everybody. We had a lot of people attending live, and thank you for all the questions. I thought there were some excellent questions, and you know, having done this last year, Eric, Carl, I mean, I think you can say there's just feels like more momentum now, and it really seems like things are really gaining traction. So I think that's such a positive thing, and I'm looking forward already to next year, where there'll be even more to talk about.
Yeah, it's absolutely. It feels really positive. And I'd just also like to plug here that if there are questions that we didn't get to cover, you know, get into the GitHub repos and post them as issues or discussions there, either on Brick side or on Rec side or on both for that matter, and we'll try to resolve that, because definitely more community engagement can never hurt.
Good. Okay, I've just been told I've got to plug the last slide. If I can find it, 1 second. Here we go. There we go. So just to finish off, everybody, if you're looking for more resources, that's where you'll find Brick and RealEstateCore on GitHub. And there as well, links to participate in the communities. And
I don't think it has turned, but I think Matthias can cut this in the final recording, James. So
okay, great stuff. Okay. I'm sorry if everyone missed that, but yeah, I'm sure if you go to GitHub and search for Brick Schema or RealEstateCore, you will be able to find it. So yeah, thanks everybody, and I wish you all a great rest of the day. Thanks, and of course, thanks to the guys for contributing tonight.
Thank you, everyone, and thank you, Jim, so much. Thank you, Matthias and Martin behind the scenes as well. Thank you, guys.
Great. Bye for now.
James, just stay.